Section 11.3 on polar coordinates. What's going on in this section? Well, let me draw some coordinate axes here. And let's suppose that you are at the origin and you're trying to go to this point over here. How would you go from here to here? Or maybe a better question is, well, how would you give somebody directions to go from here to here? So one way that you could give somebody directions is by telling them to walk, how far to walk along the x-axis. And then once they, let me make it a little bit clearer here, and once they get directly under the point, how far to walk north to actually get to the point. And this corresponds to our regular, what we would call the rectangular coordinate system. So if this point here has coordinates x comma y, you walk x units along the x-axis, and then you go north by y units. So this is a perfectly reasonable way to describe to somebody how to go from here to here. But let me redraw this picture one more time. So suppose that we are here, and you're trying to get here, and you're trying to give directions for how to go from here to here. Can you think of another way to give somebody directions to go from here to here that's not to the right x unit and north y units? I guess another way you could go north y units and then to the right x units. That would be another way. But how about a fundamentally different way? Well, instead of saying, go this, go right or go north, you could say, well, travel in this direction. I could say here, I want you to go in this direction. That's given by some angle theta off of the positive x-axis. And I could tell you how far to go. So instead of saying go along the x-axis x units, go 7 units here and then 2 units north, or whatever those numbers are, I can say, set your compass to 37 degrees, just to make up a number here, and then walk 9 units in that direction. And so this is going to be a description of what we call, well, the polar coordinate system. So we can, instead of representing a point in rectangular coordinates by x comma y, we can represent a point in polar coordinates as r comma theta, where theta is the angle. Theta is the angle from the positive x-axis, and r is the distance from the origin to the point. So I'll go on and in this video discuss more things here about polar coordinates. Let me just take a brief moment here, just do a little bit of advertisement / motivation. When you hit multivariable calculus, you will do lots and lots and lots of polar coordinates. I can think of many places in multivariable calculus in which you are using polar coordinates. And then you're using even things that riff off of polar coordinates, cylindrical coordinates. Something you learn about multivariable calculus is similar to polar coordinates with extra things going on. Spherical coordinates is shares some similarities as well. And so this is, along with the parametric things that we did in sections 11.1 and 11.2, the polar coordinate things that we're doing in section 11.3 and next section 11.4 are probably the most important parts of Calculus 2 for you to understand in order to succeed in multivariable calculus. Okay, so we've got this going on. We could say any point here. We can describe any point in the plane using the distance from the origin to the point, along with the angle that this line forms for the positive x-axis. Some observations here as we get going is, again, let me draw some axes here. So if I were to say what lines have constant x, let me draw them in this blue color. Constant x is going to be, well, here's like x is 1, here's x is 2, here's x is 3, x is 4. So constant x, lines with that are corresponding to constant x are vertical lines. If I were to think about constant y, here's y is 1, here's y is 2. Those are horizontal lines. Well, what happens if we ask the same question about constant r and constant theta? So what points have constant r? So r is the distance from the origin to the point you're thinking about. So a curve that corresponds to constant r are all points that are at the same distance away from the origin. What's a curve where all the points are the same distance away from the origin? Those are circles. Okay, what else can we do here? Well, we should also think about constant theta. Constant theta is going to correspond to, all the points on the line should make the same angle with the positive x-axis. So these are just going to be rays that emanate from the origin. So that is how another way to think about our polar coordinates here. Okay, so in the next video, we'll take a look at how to actually do computations involving polar coordinates.